All right, we're gonna have another presentation that is more present and future than past. But again, hey, you got to forgive me because we're running up against the end of history here, and the end of history equals the present, right? Or even into the future. I think we're gonna move into the future. Ooh, future, whatever. So I'm going to give a very, very brief overview of the field of cognitive psychology and what kinds of things it might study. And we'll follow that, though, we'll spend some time talking about artificial intelligence because this is definitely a way that psychology is going to change the world. Okay? And so, the cognitive psychology as a discipline is fascinating. Again, I mean, I teach a cognitive psych course, and I encourage you all to take it. It's really a fun course. It's me. It'd be hard pressed for me to say there's something that wasn't fun, except counseling. So, memory is one of the things that it studies, and it's like, how do they work or how do they not work? I mean, I am fascinated with memory, especially when we get to like how people think memory does work and how it really does work. It doesn't work the way people think it works. Concept formation, it's an interesting thing that studies how we know when you walk into a room and you've never walked in this room before and there's an object on the floor and you go, oh, well, that's a chair. Well, how the heck did you know that was a chair? You've never seen it before. Nobody told you it was a chair. And you know what? It is not exactly the same as any object you've ever seen before in your life. And you think chair is hard. Just imagine, how the heck do you know something's a dog? Oh, that's a dog. Really? How the hell do you know there's a dog? Right? That's an interesting discussion. And I promise you, the reason we're talking about this is because an artificial intelligence system needs to be able to look at it and go, that's a dog. And it's really an interesting thing. If you want to get a computer to be able to look and say, oh, that's a dog, you have to understand how humans know that's a dog. And it's not a simple thing. It's not. But it also, cognitive psychology also to some degree studies attention, which is difficult. Attention is a difficult thing. Very hard to, because really you can't, what is attention? Reasoning, though, both logical and illogical reasoning, problem solving, how we solve problems, ways that we solve problems, but judgment, and then language things, and what does intelligence mean and stuff. So cognitive psychology is a pretty broad area, okay? And within the realm of cognitive psychology, we also are interested in studying comparative cognition. And comparative cognition is the study of what other animals do. And I'll tell you the brief summarization of comparative cognition, and that is, all over the world, all animals face similar problems. Whether you're talking about humans, orangutans, chimpanzees, cocker spaniels, rats, or butterflies, okay? All over the world, they face similar problems, including things such as, I need to find something to eat. I need to find shelter. I need to find a woman. All right? These are the same problems everywhere around the world. I mean, all animals have them. And so, to a large degree, Darwin already wrote about this 200 years ago. Okay, not 200. Forgive my history blub. Okay, 150 years ago, Darwin already wrote about this and said, look, I mean, of course, since the problems that animals face around the world are exactly the same, of course they have cognitive mechanisms which are almost exactly the same. And so we find that in the study of animal cognition, there's almost no differences with human cognition as far as actual types of things. That all animals have the ability to have memory abilities, go back to this slide. All animals have memory abilities, have concept formation abilities, have the ability to pay attention, they have ability to reason, they have the ability to solve problems and form judgments. Maybe not language, but communication. We'll get to that. And they display intelligence in different ways. And so we find that the study of animal cognition is fascinating because we're really studying us and us in a simpler form. I mean, it's really quite a cool study. Okay? And so here's the thing. In the realm of cognition, if it's true that, as I just said, all animals face similar problems and therefore they're the same. Animals are the same. I mean, I'll just take you and a chimp. You're 97% genetically similar or something. Everything is the same. You're the same, you're the same, you're the same. But what's different, Alright? If you were in a different one of my classes, you'd find there is one area of the brain that is particularly different, the mirror neuron system, but that's a whole nother class for a whole nother day. But the fact is, when it comes down to this question of, so what makes us different? And I already said it when I went back to that first slide, the answer is language. It's language that makes us truly different from the other animals. Because in every other way, we're the same. I mean, don't get me wrong, your memory is better than a chicken's memory, alright? But it works the same. The same rules of how memory works and forgetting happens works with you and a chicken. It's just the time frame with a human is longer, the capacity is larger, but language is unique, okay? And again, I don't have time to get into a whole spiel on it, but I'll tell you what, anybody that ever tells you that animals have language are full of shit, alright? Because I'll give you a challenge. You tell me any animal in the world, we're talking about a dog wagging its tail, or even a monkey doing sign language. I challenge you to get any monkey to say anything like this. Tomorrow, if the weather's good, then it might be a good idea for us to go to the park, but only if it hasn't rained in the past 2 days. Whatever. I don't know how and I just made that up. That sentence has never been created ever before in the history of the world as far as I know, okay? Yet, you understood what I meant, and it involved multiple hypotheticals, it involved future tense, it involved... there's no way a monkey can do that. No matter how much you train the hell out of a monkey, he's never going to be able to do that for you. So, human language is just... it's just a world apart from other animals, whereas all other cognitive skills are really just an extension. I mean, nothing unique. And so, in fact, when we study things such as tool use, other animals use tools. Look, you got woodpecker finches underneath my face. I know, sorry, finch. Woodpecker finches that use little twigs of grass to pick out bugs. You've got a green heron that catches a small fish and then holds it out of the water and waits for the stupid big fish to come and try to get it. You use Egyptian vultures that use stones to crack ostrich eggs. Some people say that's not really tool use because they're just taking what they already found. Some say take a look at this. Say, for example, what we've got, I mean, the one under my face is the old standby. That's the one where the monkeys will take, the chimpanzees in this case, will strip a stick off the tree. They'll chew the end on it, make it all nice and juicy, and then jam it in a hole in the termite mouth. So they've not just used the stick that they found, but they chewed on it and modified it to make it more yummy so that when they stick it into that hole, termites will grab a hold of it, stick to it, and then the chimp pulls it out and got himself a termite snack. Meanwhile, we've got the little capuchin monkeys over on the left side, and the tube there is filled with yogurt. Alright? And so these poor little capuchin monkeys, see what happens is the one on the capuchin monkey on the right side of that picture there, you can see what he did is he chewed up that bamboo or something, kind of made it all spongy so that he could stick it down into the yogurt and like soak it up like a sponge. And then, so he took something that he found, a piece of bamboo, he chewed it up and made it all spongy and was able to. Okay, cool, whatever. Some people say that culture is uniquely human. Nah, culture's not uniquely human. Anybody that's ever sat through enough of my classes knows that any animal that has the ability for social learning, observation learning, has the ability for culture. All right? It allows for unique solutions to problems, unique environmental problems to be solved collectively by a group so that each individual doesn't have to discover the solutions for themselves. It's cool. It's all wonderful, but it doesn't make us human. So here I am onto the point of this, and that's artificial intelligence. Artificial intelligence is very cool. A branch of computer science that investigates the extent to which machines can simulate or duplicate the intelligent behavior of living organisms. Now, artificial intelligence is a fascinating study because, of course, I want me a flying Jetsons car. I want a car where I can just put it on autopilot, and that car drives me to work. Because you know what? While I'm driving to work, I have all kinds of things I'd rather be doing rather than paying attention to the road. Don't you? You probably are anyway. So, I want that flying Jetsons car. And that's all fine and dandy, but remember when I said, how do you know that that's a dog? Well, it's the same thing. If you want yourself your automatic driving car, you got to figure out, as you're driving along and a leaf is falling from the tree, how do you know it's a leaf? And therefore, if you know it's a leaf, is it something that you can disregard, or is it something you have to deal with? How did you know that it was nothing to be worried about? How did you know the leaf falling from the tree? And in fact, how did you know when the leaf fell from the tree and it changed direction, it changed shape? How do you know that it's not a new object? How do you know it didn't all of a sudden go from something not dangerous to something? How do you know? And the problem is, I don't know how I know. I just know. I just know that a leaf is not. I know that as it's falling, it's a leaf. I know it's not dangerous. I know that as it flutters down and changes its direction, it still remains a leaf and it is still not dangerous. How did I do it? And see, that's where artificial intelligence comes in. It attempts to figure out, how do humans know? How do humans figure it out? And then tries to teach this to a computer. Okay? And so artificial intelligence was founded by a guy named Albert Turing. I can't remember Turing, but he's a guy that broke the Nazis' code during World War II and allowed the British to spy on the Nazis. So here's the Turing test, okay? Albert Turing, Alvin Turing, somebody Turing. Gosh, I wish I could remember which Turing it is. But anyway, Turing said this. He said, okay, if you want to know whether a computer can think, here's what you do, okay? In fact, I'm going to have to move my face because there's a picture, okay? You take this person, the one in blue there is a human being, okay? And so this person in blue submits questions to a terminal, to a computer terminal, and it gets sent out to two different things. It gets sent out to another human being over there on the left and a computer on the right. And both the human being on the left, on the A, human left A, and the computer right B, their job, whatever that might be, their job is to try to convince the human in blue that they are in fact human. And so, the guy in blue will ask questions like, so what's your favorite movie? And the human and the computer are both trying to convince the guy in blue that they are the human. And if the computer can fool that guy in blue and make him believe that it is in fact the human, then that computer has passed the Turing test. Okay? And so it's an interesting question of, what does it mean for a computer to be intelligent? And according to this definition anyway, a computer is intelligent if it can fool a human being into believing that it is in fact a human being. As we know in psychology, operational definitions are everything, right? This is just one possible definition of artificial intelligence, because other people would argue this. They would say, I don't know. I mean, you can use that definition all you long, but just because somebody has been fooled doesn't mean that the computer thinks like a human. Okay? And so they argue against the difference between weak AI and strong AI. And weak AI is this notion that you might get a computer that can fool somebody into thinking, passes the Turing test and fools them, but it does so in ways that are absolutely unrelated to a way a human would do it. Okay? Strong AI says that you could get a human that thinks like, or you could get a computer that thinks like a human. Weak AI says you could get a computer that acts like a human but doesn't look like a human. Okay? And so remember, there's this Roger Sterling. He had this, I think he called the Chinese room problem. I love this. This is great. Imagine this. He wants to show that Roger Sterling wants to show that strong artificial intelligence is a load of crap. It'll never happen. So he says, imagine you're put into a room and you're told, okay, what's going to happen is you're going to get these weird characters coming through on a piece of paper. And your job is to look at the characters that come through on the piece of paper and then look in this big instruction book over here. And in this instruction book, it's going to say this. It's going to say, if these squiggly characters come in, then go over to this bucket here and pull out these characters and send this back. Okay? And so, meanwhile, you don't know what the heck you're doing, but you're like, I can follow instructions, no problem. And so somebody, you get this piece of paper and it's got, you don't know what it says? I don't know what this means. crap on a page. He says, but you know what? You go to the rule book, and the rule book says, okay, if that particular combination comes in, I should create this combination and send it back out. Bing, and you do it. And you go back and forth a few times. You don't know what you're doing. You're just following the rule book. All right? And meanwhile, the person that's sending this stuff in on the other side is a native Chinese speaker, and it turns out they were sending you Chinese letters, and you're sending Chinese characters back, and the person on the other side goes, dude, you can speak Chinese. You're like, what the hell are you talking about? I can't speak Chinese. I'm just following the rules in the rule book. And Roger Serling says that's what computers are. They're just reading a rule book. They don't know what the hell they're looking at. They just if if these ones and zeros come in, then these ones and zeros go out. They don't know. And so the better the rule book is, the bigger the book of rules, that is, the more cases that are covered, the more likely that that computer can make itself look as though it speaks Chinese or is human. Okay? But it never will be human, because it's ultimately nothing more than, just like your little Chinese room problem, it's nothing more than looking in a rule book, pulling it out, saying, if this comes in, then this goes out. Okay? Very cool stuff. And so I'm going to stop with this today, but cognitive psychology is fascinating. Artificial intelligence is fascinating. We are on the cutting edge. Between this and biopsychology, we are on the edge of all technology here. Clearly what we're finding is that the better the computer systems are, and in fact we're at a world here where they're starting to create a whole new kind of computers called quantum computing, and they'll confuse the crap out of you if you ever read about quantum computing. It's just, oh my god, it's just crazy confusing. But we're entering a realm where, the idea of strong AI may not be impossible, as Roger Serling was saying, because we're going to find, at this point, the way computers are created, don't get me wrong, as they get faster and faster and faster, that's all they are, is faster and faster and faster. They're not better. They're always, every single time there's a new technology upgrade, it's the same shit, all right? They just made it faster. But we're entering a realm of quantum computing, and we may get to the point where strong artificial intelligence is actually possible, all right? If quantum computing works out the way I believe it will, we have entered the realm of strong AI. So when that happens, be careful. That's when robots will take over the world. Doom. So I will stop her there and then give you a rest, take your nap, and we'll come back, and I think we only have 2 more videos left in this wonderful course of ours. All right? So I'll see you again later.